A higher degree polynomial is a polynomial whose degree is greater than 2. Some examples would be something like x cubed minus 4x, or x to the 5th plus 3x to the 4th minus 7x plus 1. We want to try to factor higher degree polynomials so that we can solve higher degree equations. And we apply the same strategies that we have used to factor trinomials and binomials and so forth. So we first want to begin by factoring out any common factor, and then we determine if the polynomial is a binomial, trinomial, or a 4-term polynomial. If we have a binomial, then we will apply either difference of squares, difference of cubes, or sum of cubes, and use the appropriate factoring pattern. If it's a trinomial, we will apply trial and error or the AC method, and if there are 4 terms, we will apply grouping. Let me go through some examples of each of these. The first one is x cubed minus 64x. Note that there's a common factor of x between the terms, so we factor out an x, and that leaves x squared minus 64. X squared minus 64 is a binomial, and notice that each term is a perfect square, and so we can factor this as a product of conjugates. And the terms in the conjugates need to be, what do we square to get x squared and 64? And that would be x and 8. And we have to have the difference and sum of those terms. In b to the 5th minus 8b squared, this is a binomial, but there is a common factor of b squared. And if we divide out b squared from each of the terms, we're left with b to the 3rd minus 8. Now b to the 3rd minus 8 is a binomial, and notice that each of those terms is a perfect cube, so we factor this using the factoring pattern. And if you recall that a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So the terms in the binomial are what we cube to get b cubed and 8, and so that would be b and 2, and the first sign is the same. And then we obtain the trinomial using this factoring pattern. We have to square b to get b squared, then take the opposite sign, form the product. B times 2 is 2b. Last sign is always positive, and we square the 2 to get 4. Next we have y to the 4th minus 10y squared plus 9. This is a trinomial. There's no common factor among the 3 terms, and so we try to obtain the 2 binomials whose product is this trinomial. The factors of y to the 4th are y squared and y squared. Then we need to find the factors of 9 whose sum is negative 10. And the factors of 9 are 1 and 9, or 3 and 3. The only way to get the sum of negative 10 is the negative 1 and negative 9. So we have y squared minus 1, y squared minus 9. Now the thing with higher degree polynomials is that sometimes you can factor further after you do that initial step, and so that is the case here. Y squared minus 1 is a difference of 2 squares, so that's y minus 1 times y plus 1. And then y squared minus 9 is y minus 3 times y plus 3. The last example is 4a cubed plus 12a squared minus 9a minus 27. Note that this is a 4-term polynomial, so we apply grouping. We group together the first 2 and the last 2. And in doing that, now we look for the common factor between the first 2 terms. between 4a cubed and 12a squared, there's a 4a squared in common. Dividing each of those terms by 4a squared leaves us with a plus 3. Then between negative 9a and negative 27, there's a negative 9 common. When we divide each of those terms by negative 9, negative 9a divided by negative 9 is a. Negative 27 divided by negative 9 is positive 3. Now we're still not in the factored form because we have a difference, but we do have a common factor of a plus 3. So when we factor that out, we're left with 4a squared minus 9. But 4a squared minus 9 is a difference of squares, so we can factor that further as a product of conjugates. And we need a 2a minus 3 and a 2a plus 3.